Hey guys, this is the start of part 2, which we will be doing molecular compounds, which are covalently bonded together, which recall from the last part was that they share electrons. Also recall, molecular compounds are two or more nonmetals. So we're not going to be focused on charge right now, we're just going to be focused on valence electrons. All right, so right now we're just looking. We know that water is H2O. We know that these will share. Okay, they share. Remember, the goal is to have 8. So we know oxygen needs one more hydrogen attached to it, which is why there are 2 hydrogens for water. Again, I do not want y'all drawing them like this. I really want you drawing them like this. I do not want dots in between them. I only want dots at the top. I do want you to draw the one that I just boxed in, and I want you to write a bond. This is also called a bonding pair, and this up here is called a lone pair because it is alone. I will tell you a bond has 2 shared electrons. Okay, 2 of them. It's called a bonding pair. So every line has 2 shared electrons. Then the lone pair, obviously you can see they have 2 electrons, but they're not shared. They just belong to oxygen. All right, so these are just some examples. These are of diatomic molecules specifically. So in order for chlorine to have 8, that is why it comes in 2s, or diatomically. It's because they want to share to have 8 valence electrons. They only need 1 more. If they share their 2 single electrons, they each have 8. Hydrogen only gets 2. So you definitely need to write down. So I would say hydrogen gets a duet. Okay, so hydrogen only gets 2 electrons, and I would say no dots because we're going to use these bonds here, and I don't want to see any dots on hydrogen at all. Okay, oxygen has something that's called a double bond. Now, remember the line means 2 electrons. So in a double bond, the atoms are sharing 4 electrons, and then they each have 2 lone pairs attached to them. Again, this is how I would want it to look with the lines, not with the dots in between them. Nitrogen shares a triple bond. A triple bond has 6 electrons because, again, each line has 2. And then they each get a lone pair, which give them each 8 valence electrons. So again, the goal is to share. We will have steps in just a minute of how we're going to do that. Okay. These are the steps to drawing a covalent Lewis structure. You have to follow the steps. If you do follow the steps, you should be good. If you do not follow the steps, you're going to be completely lost. So step 1, write the correct skeletal structure. Now, it is important, and it's still here. I know it's not red, but write the correct skeletal structure. Okay, 2 guidelines are very important. 1, hydrogen has to be terminal. This just means an outside atom. Hydrogen cannot be in the middle. That's what it's telling you. It can never be a central atom. Also, hydrogen can only get a duet, which again, we already wrote. Hydrogen does not get dots. Okay. Second, it tells you many molecules are symmetrical, which is good to know. That just means that if it's got several atoms of the same type, they are generally on the outside or terminal positions of the structure. All right, step 2, calculate total number of valence electrons. So I'm going to kind of start doing this as we go through. I'm going to do NH3. So the skeletal structure for NH3 looks like this. I know that hydrogen cannot go in the middle. They just go on the outsides. So nitrogen must be my central atom. Now there's a whole lot going on this slide. I need you to count the total valence electrons. So I know that nitrogen has 5 valence electrons. And I know that hydrogen has 1, but there are 3 hydrogens. Y'all, please use your PEMDAS rules. This says 5 plus 3 is 8. This is not 18 electrons. You have to count the total valence electrons, and you have to make sure that if there's a charge, which we'll look at that at the end of this one, that you are paying attention and that you're either subtracting or adding those electrons to the total. All right, distributing the electrons. Y'all, this is step 3, distribute electrons. After you distribute electrons, okay, it says begin by placing 2 electrons between each pair of atoms. So really like the first sub-step after you distribute them or while you're distributing them is to single bond outside atoms to center atom. Okay, so again, we had our NH3. This was on our last slide. Sorry, y'all. All right, y'all, I think he's done. All right, so this is what we had. So sorry about that. He heard a noise from outside. We decided it had 8 valence electrons. We draw a single bond. Now remember earlier I said single bonds have 2 each. I drew 3 of them, so I'm going to subtract 6 electrons from it. So I have 2 left because I've already used 6. Then you place six dots. That's because we want 8 total, and there's already 2 in each line on the outside atoms. Okay, but remember in this case, hydrogen can't get dots, so we go to number 3, place remaining dots, or remaining electrons, on central atom. And this needs to be done in pairs. Okay, so I have 2 left, we pair them, there they are. So this is my structure, my Lewis structure. You need to follow those steps that I handwrote on this slide. You single bond them first, you subtract that amount. You place 6 dots on outside atoms if you can, you subtract that amount. You place anything that's left on the center. If you do not have an octet, so this is like the last step, it's like checking that you have an octet. So we did have this. Remember, hydrogen can only have 2, so all of our hydrogens are good. Now, nitrogen has 2, 4, 6 in the bonds, and then 2 alone, so that's 8. This one is done. We do not have to do anything else. If you do not have an octet, and you've used all of your electrons, these 5 elements can double or triple bond. Double or triple bond. Only those 5. No other element can double or triple bond. And I'm stressing this, it is very important. Only C, N, O, P, and S can double and triple bond. And it only does it when you do not have enough electrons. Okay. So the next one is CO2. It's going to go through it, but it's easier to see as I'm going through it. So C goes in the middle. I will tell you, if C is present, it 100% needs to go in the middle. We are carbon-based life forms. Carbon goes in the middle. There's our skeletal structure. We count valence electrons. So I have 4 plus 12 is 16 electrons. Again, those come from the A's at the top of the periodic table. We single bond them. Sorry, I don't like that that O has like a tail. I subtract that amount. So there's 4 because there's 2 bonds. I have 12 electrons left. 6 on each outside atom. Not the middle atom, the outside atom. And y'all, that uses all 12. So now I'm down to 0. At the point where we're at 0, you cannot add any more dots. You do not have more dots to add. You need to Sorry. My dog is on my laptop. At this point, carbon only has 4, as you can see in the bonds. So what's going to happen is I'm going to take a pair of electrons and I'm going to move them. When you do that, please make sure you erase those electrons. So now carbon has 6, 2, 4 on the right side and 2 on the left. That means 6. Remember earlier I said that they like to be symmetrical, so we do it on both sides. This is not a very pretty structure. We are not going to leave it like that. We are going to finalize it so it looks like this down here. This is much neater of a structure. Okay, so there is our CO2. So again, it walks you through them, count them, draw the lines, do this stuff. All right, for CO. CO is 4 and 6. When there are only 2 elements, there is no center. So that's 10, I subtract 2, that's 8. At this point, I don't care how you distribute it, because you can do like this. You can do 4 and 4, you can do 6 and 1. It doesn't really matter. You run out. Nothing has 8. So I'm going to erase this bottom set and double bond. So now the carbon has 8, but the oxygen does not. So now I'm going to erase the pair from carbon, triple bond. So now both of them have 8. This is our answer. All right, now we're doing some easier ones. We've got CCl4. Carbon goes in the middle always if it is present. Okay, so carbon has 4. Chlorine has 7, but there are 4 of them, so that is 32 electrons. I bond them. That is 8. So I've got 24 left. Remember, the outside atoms get 6 dots each. Y'all, please remember these dots come in pairs. They're called lone pairs. That one's hard to see. There we go. Okay, that is 24. Everybody has 8 in this drawing. It is done. Completed. Okay. I think this is the last one. So again, carbon goes in the middle. If you have carbon, it has to go in the middle. I've got 2 from hydrogen, 4 from carbon, 6 from oxygen. That's 12. I already bonded, so I subtract 6. Now remember, hydrogen cannot get dots, so the only outside atom that gets dots is oxygen. Okay, when you do that, you use them all. Carbon only has 4, you double bond. Remember, only CNOPs can double and triple bond. It is very important that you remember only CNOPs. All right, last thing for today is that we're doing polyatomics. Y'all, there's a lot of red going on this slide. It's really just telling you, remember, you add an electron if it's negative, and you subtract an electron if it's positively charged. That's it. So on this slide, we're going to draw cyanide. Notice it does tell us the charge. It's negative, so you have to add 1 valence electron. It did already count it for us, so there's 10. I'm going to bond it. I've got 8 left. I'm going to put them on nitrogen. It doesn't matter where they go. I'm going to put 2 on carbon. Okay, carbon only has 4. You have to move a pair. Carbon only has 6. You have to move another pair. When they both have 8, it's good. Don't forget, though, if they have a charge and dots, they have to have brackets. Very important. They need brackets. So there's our final picture, just like we did. All right, let's do another one, NH4. So this one's a positive one. We've got 5 from N, 4 from hydrogen, but we're subtracting 1 this time because we're a positive charge. That's 8. Nitrogen goes in the middle. We put them around the outsides. We bond them. That is all 8, and we're at 0. So nitrogen has 8, hydrogens have 2. It is done besides the brackets and the charge. You do have to show the charge. If you do not, it is wrong. Okay, we're not going to do that one. So that is it for this video. I hope y'all have a great day.